We are live, sir. We can start.
Okay. Okay. Good morning, everyone. Welcome you all to the GATE Academy. Welcome you all to another Power Booster session. A session which is meant to do the revision in the quickest possible time. Okay, we have already covered few questions in our last class, in our last session. Let me tell you what are the topics which have already been covered. First of all, let me tell you which are the topics which have already been covered. Whether it is fluctuating load, whether it is from bearing, or whether it is gear. Okay, we have seen the types of variation, the possibilities which are possible over there. Now we are going to see what are the variations and or what are the questions which are possible, or what are the formulas which are possible as far as second part of machine design is concerned. If I will say that what are the topics which are left with us, then those are clutches, brakes, spring, and apart from that, joints. Okay, we will try to watch each and every variety of question, each and every variety of concept basically. Okay, we will be doing some questions, and with the help of those questions we will be watching all the other concepts as well. So hope this session will be helpful to you. Very good morning, Vijay. So whoever will join, keep on commenting in chat box whatever your issues are, whatever doubts you are having right now, or whatever doubts you are having with the concept, you can ask over here only. Okay, that is the beauty of a live session, that you can ask here and we can have this conversation. We can have this, you can say, from you to me and from me to every one of you. Okay, so we will start with clutch. Now, first, before starting the problem, let me tell you what are the possibilities, what are the types of questions which are possible over here. So, starting from the first point, that you should be having the idea of wear theory. You should be having the idea of pressure theory, uniform wear theory and uniform pressure theory. Okay, so we will go through the revision of each and every point, and then we will solve. Try to understand this. As far as machine design is concerned, we should be very aware of the fact that you can score, say for example, if they have asked 6 marks, okay, from machine design, then out of this 6 marks you can score complete 6 marks. Why? Because this subject is application based subject. This is not a basic subject where the variation or the possibilities of types of questions are too much. Here they are supposed to ask question from a definite topic in a definite way. Okay, so everything is definite, therefore it is quite possible for you to get these 6 marks completely. Am I understandable to you? You are getting what I want to say, and you should also approach the subject like that only. You should be having this clear idea that what are the formulas and what are the concepts and what are the precise concepts. Okay, it is not like that there is so much to learn and we can take something from there. Whatever here it is already very less, and you can completely go through it. You can completely revise it within a smallest span of time. Okay, so let's begin. Now keep on revising with me. So if I will say that uniform wear theory, what does that mean? Uniform wear theory is applicable when the clutch is old. First thing, uniform wear theory, instead of P is equal to constant, we say P into R is equal to constant. What is P? P is the intensity of pressure at any radius R. Is equal to constant. Okay. How it comes? It comes from the fact that the wear out of any radial distance is same when uniform wear theory is applied. Okay, that much is not required, but PR remains constant over here. If I will say what is the amount of torque which can be transmitted by the clutch when it is following uniform wear theory, then MT is the amount of torque, mu and RF. What is mu? Mu is the coefficient of friction between two plates. Good morning, Disha. Mu is the coefficient of friction between two plates. N is the normal reaction force between the two plates. If I will say that what is the value of N, then N can be determined by the help of 2 pi R, right, like this, E into 2 pi R, Rho minus Ri, 2 pi r, ro minus rf. Just see here, this is area and this is the P. This is area and this is the P. What point you should remember from here? What point you should keep in mind from here? That here I am writing PR, and for every value of R there is different value of P. But whatever value of P you are writing over here, corresponding to that only you have to write R over here. Okay, so you can say like this also, that P into R can be replaced by Pi Ri, 2 pi Ro minus Ri, or PO Ro into 2 pi Ro minus Ra. So this is the point which you should keep in mind. Good morning, Jitul. Are we getting this point? Are we getting this point here? Because PR is equal to constant and P is changing with R as we are moving away from our center. Then the intensity of pressure keep on decreasing. Okay, so at wherever point you are writing P, corresponding to that only you can write R. If you are writing Pi, then corresponding to that you have to write Ri only. Okay, what about RF? RF can be considered as equivalent radius. In case of uniform wear theory, RF is equal to Ro plus Ri by 2. In case of uniform wear theory, Ro plus Ri by 2. Okay, now if I will say that what is uniform, this much was as far as uniform wear theory was concerned. Now we can say, what about uniform pressure theory? Uniform pressure theory. In uniform pressure theory, as the name says, instead of PR is equal to constant, P becomes constant. P is equal to constant. Okay, if I will say what is the value of MT which can be transmitted, this is applied for new clutches. What is the value of MT? Again, mu n RF. What is the value of N? Again, here it is very easy to calculate the value of N. Why? Because the pressure intensity is constant, so you can directly go for area into P. What is the area? Pi into Ro square minus Ri square into P. P is constant only. Okay, so here you don't have to worry about what should be the value of P corresponding to what should be the value of R. Here the P is constant, so one value of P is enough to determine what is the intensity of pressure throughout. Okay, so P into area directly. And what about RF? RF is equal to 2 by 3 Ro cube minus Ri cube upon Ro square minus Ri square. Is it clear? So these are the formulas which are very important in order to revise the clutch portion. If I will say that which one is having greater ability of transmitting torque, then uniform pressure theory can, with the help of uniform pressure theory, whatever torque we get, or say for example in new case, when the clutch is very new, then in that case the torque transmitting capacity of a clutch is quite high. But in order to have a safe design, whenever we will design for clutch, then we will use uniform wear theory. By the help of that only we will be getting a safe design. If we will design as per uniform wear theory, then that amount of torque can be transmitted even when the clutch is following uniform pressure theory. But if you will design as per uniform pressure theory, then that will be a failure when it will convert into uniform wear theory case. Okay, as far as bearing was concerned, if I will say that what about bearing, then in bearing we go for uniform pressure theory. Why? Because here the friction is something of use, and there the friction is something which is responsible for the loss. So there, as far as safety was concerned, take the higher value. Here, as far as safety is concerned, or you can say as far as the failure is concerned, you have to take the lower value. Considering that, you should keep in mind that bearing is designed as per uniform pressure theory, and clutch is designed as per uniform wear theory. So this is also a point which you should keep in mind. Why? Because this time it is multiple select type question, and you should be having some idea of theory point of view also. Okay, now apart from that, if I will say that what about multi-plate clutch, instead of single plate clutch, if I am having multi-plate clutch, then in that case, in case of multi-plate clutch, you can have the value of MT to be mu n RF into n, mu n RF into n. N is the number of surfaces in contact. N is the number of surfaces in contact. Say for example, these are the plates which are mounted on driving member, and these are the plates which are mounted on driven member, driven shaft. Anyhow, so here n is the number of contact surface. Say for example, here it is 1, 2, 3, 4. Now in such cases where the number of plates are less, you can find it easily. But what about if the number of plates increases? Then in that case, what you have to do, you have to apply a formula that in order to determine the number of surfaces in contact, we have to write n1 plus n2 minus 1, n1 plus n2 minus 1. So this is another formula which you should keep in mind, where n1 and n2 are the number of plates on driving and driven shaft. Is it clear? So these are some formulas which you should keep in mind. Apart from that, there is also cone clutch, however never asked, but just we are going through revision, so we will see everything. Now cone clutch, empty becomes how much? Empty becomes mu n RF upon sine alpha, by 1 by sine alpha times the torque transmitting capacity increases. We know the value of sine alpha is always less than 1, so the torque transmitting capacity of a cone clutch is increased by 1 by sine alpha times. What is alpha here? Here alpha is the semi-cone angle. That we should keep in mind. Okay, so this will be your imaginary cone, and this will be your cone angle theta. So alpha, whatever alpha we are using, it is equal to theta by 2. So keep this point in mind, that alpha is the semi-cone angle. What about centrifugal clutch? How we are going to determine the torque transmitting ability of centrifugal clutch? Just see here, same thing. Okay, try to understand here that I am not writing everything separately for RF over here. Okay, if it is following uniform pressure theory, then we have already seen that what RF will be. If it is following uniform wear theory, then we have already seen that what will be the value of RF. So we don't have to see again and again what is the value of RF. It is only the concept of N and sine alpha which will be added in case of multi-plate clutch and cone clutch separately. Are we clear? Everyone? Is this point understood to you? Okay, you don't have to worry regarding RF and everything again and again. Now, if I will ask from you, what about centrifugal clutch? What about centrifugal clutch? Here also the same thing will be there. What mu n RF is the amount of torque which can be transmitted. Now here the value of determining n will be different. Say for example, this is your drum. This is your block. And same is the condition. I haven't drawn over here. Same is the condition throughout the 360-degree angle. Okay, means say for example, I am talking only about one block. Similarly, there will be n number of more blocks over here. Let us calculate what is the amount of torque basically which it can transmit. Now once it will come in contact, there will be normal reaction force between both of them, and since the shaft is rotating, so the block is having tendency to rotate in one direction, to basically move in one direction, and corresponding to that it will ask the drum also to move in the same direction. Say so is the case. Now, if I will say that what will be the value of n, let us calculate what is the value of mt. So mt is equal to mu into n. N is how much? N is the difference between the centrifugal forces. The difference between the centrifugal forces. What are the different centrifugal forces? Two centrifugal forces we are talking about. One centrifugal force is the force when it was just reaching to the contact, and second is the centrifugal force corresponding to the situation present. Means, say for example, if at omega I this block come in contact with the surface, this is omega I, and omega O is the instant we are talking about. Right now it is rotating with omega naught. Right now it is rotating with omega naught. So corresponding to that, it will be having two different centrifugal forces. One is m rg omega naught square, and the another initial one was m rg omega I square. Now the difference of the two will provide you the amount of normal reaction force which is acting in between two. What is the value of rg? What basically rg is? Rg is the position of center of mass of the block. Rg is the position of center of mass of the block. We all know that centrifugal force is an inertial force, and inertial force is equal to mass into acceleration of center of mass. Mass into acceleration of center of mass. What will be the acceleration of center of mass? It will be mrg omega square. Mrg omega square. What will be the direction? It will be opposite to the direction of radius. Okay, we can say radially outward. What at which point it will be acting? It will be passing from rg itself. So the value of n in between both the blocks can be calculated like this. So you can directly write here m into rg omega O square minus omega I square. Now, after writing this formula, this is the amount of friction force. Now, what about the amount of torque? Amount of torque will be, this is the amount of friction force which is applied at this surface. Now, what will be the value of friction torque? Torque because of this friction. Now, if I will say that, say for example, the radius of drum is given by rd, then in that case you have to multiply this force into rd to calculate the value of torque. So this will be multiplied by rd. Now this formula is corresponding to one block only. So in order to determine the net torque, we have to multiply it with number of blocks. So you can say that if, say for example, if the number of blocks are z, then this will be a formula. Write down that z is what? Z is the number of block. Rg is the radial distance of center of mass, okay, or centroid or center of gravity, whatever you can write. Radial distance of center of mass of every block, because it will be symmetrical anyhow. Therefore, you can say that each and every block will be at the same radial distance. Okay, so radial distance of center of mass from axis of rotation. Rd is how much? Rd is the inner dia of drum. Omega O is angular velocity at this instant. At this instant. What about omega I? Omega is the angular velocity when the contact begins. Contact begins. Okay, now everything is I think you got what each and every term represent. Is it clear? So these are the points which you should keep in mind when you are revising for clutches. Are we clear regarding this? Class? These were the points which you should keep in mind in order to revise clutches. Now we will go for problem. The problem says that a plate clutch consists of one pair of contacting surfaces. The inner and outer diameter of the friction is provided. This is di 100 mm. This is du 200 mm. The coefficient of friction is mu is also provided 0.2, and the permissible intensity of pressure. Let's write it to be P, 1 Newton per mm square, 1 megapascal. Assuming uniform wear theory, calculate the power transmitting capacity of the clutch at 750 rpm. 750 rpm. So N is how much? 750 rpm. So if I will ask you to solve this question, understand this. In this question they have provided, try to understand this. In this question they have provided what? That it is following uniform wear theory. Now di, we are very clear what di is, what do is, what mu is, what n is. Everything is very clear to us, but we are not very sure about what does this p signifies. Because here the p is not constant definitely. Whether it is PO, this is PI, or this is any random value of pressure intensity, but we know that PIRI must be equal to POR. This is the something which we know as far as uniform wear theory is concerned, because PR remains constant. So we will say that PI by PO will be equal to RO by RI, and this is obviously that RO by RI is greater than 1. It is obviously 2 over here, but it can be anything but greater than 1. So RO by RI will always be greater than 1. This is something which understood to everyone. Okay, so PI by PO must be greater than 1. This is something which we got to understand from our intuition, that PI by PO must be greater than 1. Now in this question they have provided the allowable intensity of pressure is 1 Newton per mm square, 1 megapascal. So in case if you are going to take PO to be 1 megapascal, then in that case what will happen? PI will become greater than 1 megapascal. It will become greater than 1 megapascal, and it is not allowable as far as design is concerned. So we are going to take PI to be 1 megapascal, because it is always the internal pressure. Which is highest, because the value of Ri is the lowest value. So you can say that always the PI value will be the highest value, and here it is said that the highest value of stress allowed is 1 megapascal only. So we got the value of PI to be 1 megapascal. So definitely this value, whichever is provided to us, is PI only. Okay, so from here we have concluded that PI must be greater than PO. So this P is PI. Now in order to determine the power transmitting capacity, we have to determine the value of power. Power is how much? Torque into omega. Empty is how much? Empty is equal to mu n RF. You can calculate mu to be 0.2. N can be calculated as 2 pi Ri into Ro minus Ri. This will be your area, and into Pi into RF. RF will be Ro plus Ri by 2. This is your formula. So you are going to put over here as 0.2 into 2 pi Ri minus Ri into Ro minus Ri. Okay, so if you are keeping PI in megapascal, then you can keep area in mm square only, in order to get the value of N in Newton. Okay, but you have to keep in mind again, you have to in order to get the value of MT in Newton meter, you have to keep the value of Ro plus Ri by 2 or RF in meter itself. Okay, so this is something which is about units only, so that you can have this idea basically how to keep the units, whatever unit we want. Okay, so this will be 2 pi into Ri is how much? 50 into 50 into 1 megapascal. So this value will be in Newton. Now we want the torque to be Newton meter. So this value should be in mm only. Ru plus R by 2 means 0.05 plus 0.1 by 2. This value will be 235.6. Are we getting this value? 235.6, 235.61, 235.61. This is the value of torque in Newton meter. Now we have to determine the power transmitting capacity. So in order to determine the value of power, we need the omega in radian per second. Radian per second means 2 pi n by 60. 2 pi n by 60. This value will be 2 pi into n. N is how much? N is provided as 750 rpm. 750 rpm. It was also possible that we would have got the value of omega directly in radian per second. In that case, we don't have to convert anything. Okay. So this will become 78.53. 78.53 radian per second. What will be the value of power? It will be 235.61 into 78.53. This value will be 18.5 kilowatt. 18.5 kilowatt. This will be your answer. Is it clear? As far as, very good Vijay, as far as clutch is concerned, there is, you cannot get very tough question. These are the only concepts which are possible, and we have covered every one of them. Are we clear? Everyone, are we clear about this? Now let's move to the next question. Let's move to the next part. Basically, a single block brake torque capacity with a torque capacity of 250 Newton meter is shown in figure. The coefficient of friction is 0.35. Calculate the actuating force and the hinge pin reaction for the clockwise rotation of drum. For the clockwise rotation of drum. Okay, try to understand this. This clockwise rotation is very important. This clockwise rotation is very important. If you will not keep in mind this clockwise rotation, then you will not be able to solve the question of brakes, whether it is block brake or whether it is band brake. Okay, whatever brake it will be, it will completely depend upon the rotation of the drum, in which direction the drum is rotating. Okay, or in which sense the drum is rotating. Basically, here we have to determine pin reaction also, apart from calculating actuating force as well. Okay, so before starting, let me tell you that here we are going to discuss about self-energizing and self-locking brake also. Self-energizing and self-locking brake also. Okay, what it will mean, what the self-energizing, by self-energizing, what do we understand? And apart from that, we are also going to discuss about the types of band brakes. Okay, so here only with the help of this question only, because we are not going separately for different questions as far as brake is concerned. One question, and apart from that, whatever we have done in previous question, that we have gone through all the formulas, all the concepts which were possible to have in that chapter. Same thing we will be doing over here also. Okay, so let's start. It is very important to have the idea of free body diagram. It is very important to have the idea of free body diagram as far as machine design is concerned, as far as this portion is concerned, clutch, brake, and rivets and all, everything. Okay, let's see here. So if I will ask you to draw the free body diagram, Let's see here. Because of this actuating force, this block is going to push, this drum. And because of this push, there will be action and reaction. The drum will also push the block back. Okay, so say for example, this is the normal action force which is acting. Now, since this is rotating in clockwise rotation, this is rotating in clockwise direction, you can say. However, the direction of rotation is not clockwise. It can be determined. Direction of rotation is clockwise only. But if I will say that what will be the amount of torque because of this friction, then it will not be anti-clockwise. It will be calculated. Direction will be calculated using right hand thumb rule. I think every one of you are aware of that. Okay, so this will be, say for example, this is friction. Corresponding to that, this is also friction, action reaction. Okay, this is Rx, Ry. This is the actuating force. If I will say that what are the number of unknowns, so number of unknowns are too many over here, P, F, N, Ry, Rx. So number of unknowns will appear to be 5. But the thing is, here the friction force is dependent upon normal action force. So if we will know the value of N, we will know the value of F also. So here the number of unknown will be 1 only. So total number of unknowns will still be 4. The system of force is non-concurrent system of force. So we need to have only 3 unknowns. For that, we must be having some more details in this question. Okay, let's check that. A single block brake with a torque capacity of 250 Newton meter. This torque capacity will help us to determine the value of F or N, whatever. Okay, so we know that what is the amount of torque or braking torque which is applied over here is mu into N, or you can say directly mu into N into R. Radius of drum is provided with 200 mm. So this will be 0.35 into N into R. R is 0.2. Empty is how much? Empty is 250. From here you will get the value of N to be 250 divided by 0.07. 3571. N is 3571.42 Newton. N is 3571.42 Newton. Once we will got the value of N, then we definitely got the value of F also, because F is nothing but mu into N only. So this is 3571.42. And what about F? F is 0.35 times of that. So F is 1250 Newton. 1250 Newton. Now we will talk only about the free body diagram of this lever, which is also having block, which is having the reaction from the hinge joint, which is having one actuating force as well. Okay, so the number of unknowns remain only 3. We can determine those 3 unknowns with the help of equation of static equilibrium. What are those 3 equations? Summation Fx equal to 0, summation Fy is equal to 0, and net moment about any point is equal to 0. So from there we can write that summation Fx is equal to 0. By summation Fx equal to 0, we can directly say that Rx must be equal to 1250 Newton. How we are saying that Rx must be equal to 1250 Newton? Because there is no other force apart from Rx and friction in horizontal direction. So we can directly conclude that, okay, as far as direction we have assumed for Rx is directly going to be the value of 1250 only. Now, if I will say summation Fy is equal to 0, from there we will say that P plus Ry must be equal to N. P plus Ry must be equal to N. And if I will say that what is N? N is 3571.42. This is also our second equation, which is perfectly correct. Net moment about any point will also be 0. Here we are going to take about O, because in that case Ry and Rx will not appear into our equation, and it will be easy to calculate the value of N or P correspondingly. Okay, here we know the value of N, so we can calculate the value of P very easily from here. So the value of moment, net moment about O is equal to 0. From this equation we can conclude that P into A plus B, P into A plus B must be equal to into A plus B. It is responsible for anti-clockwise torque. Okay. F is also, friction force is also responsible for anti-clockwise torque only about point O. We can see that with the help of moment arm. How to calculate the value of torque because of this F? We have to look for the moment arm. What is the moment arm? Moment arm is the perpendicular distance of line of action from point of rotation. So this will be 50 only in case of F, and it will be equal to A plus B. Moment arm will be equal to A plus B in case of P. Okay, so we can directly go for P into A plus B plus F into C is equal to, this is C, this is your C, must be equal to how much? Clockwise must be equal to anti-clockwise. Anti-clockwise is how much? Anti-clockwise is N in, sorry, anti-clockwise was this much. Clockwise is how much? N into B, N into B. So here you can place at P into 500 plus F is how much? 1250 into 50 must be equal to 3571.42 into 200. We have calculated the value. Please answer. 3571.42 into 200 minus 1250 into 50 divided by 500. 1303. The value of P will be 1303 only. The value of P will be 1303 only. P is equal to how much? 1303 Newton. Now, if I will say that what will be the value of reaction at O, what will be the value of reaction at O, support reaction at O, then it will be the resultant of Rx and Ry, because Rx and Ry are mutually perpendicular to each other. So you can say that under root of Rx square plus Ry square plus 2 Rx Ry cos theta. Cos theta becomes cos 90, cos 90 becomes 0. So the value of R will be under root of, okay Vijay, under root of Rx square plus Ry square, Rx square plus Ry square. We have to determine the value of Rx. Rx we directly know that it is 1250 Newton. What about Ry? Ry can be calculated using equation 2. Ry can be calculated using equation 2, because we know that now the value of P is 1303 and P plus Ry is equal to 3571. So from here Ry will be equal to 3571.42 minus 1303. So this is 2268.42 Newton, and R will become equal to under root of this. R will become equal to under root of this. It will be 2590. R will be equal to 2590 or something else. 2590 Newton. 2258 is not possible. Ha, 2590, 2589, around that only. Ha, Vijay. Okay. I think you have written something like 2258 also, but that is that I don't know what. Okay, it was 2558. Okay. There must be some calculation mistake or something. Okay. Now we are you are getting the right answer. Okay. Right now you are getting the right answer. So these are some of the points which we have kept. What in we have to be very sure about the rotation of drum. Why? Because if the rotation of drum will change, then however the normal reaction force direction will not change, but the direction of friction force will change. And when the friction force direction will change, then every calculation will change accordingly. And corresponding to this only, the direction of friction only, we have decided some terms, we have given some terms like self-energizing brake. If the direction of friction is such that, the moment because of friction force and the actuating force are in same direction about hinge point, then in that case we will say that this type of brake is a self-energizing brake. Why this name self-energizing comes? Because the friction is also, you can say that it is providing support to P in one way or other, in order to balance the moment because of normal. It is supporting the P, it is supporting the actuating force. Now we have to keep the low value of actuating force in order to get the same conditions. Are we getting this? Therefore we say that this is a self-energizing brake. Once again I'm saying, a self-energizing brake is that brake where the friction is acting in such a way, that it is supporting actuating force. How it is supporting? It is supporting when the torque because of actuating force and the torque because of friction force are in same direction, as it is happening over here. The actuating force is also causing anti-clockwise moment, and friction force is also causing anti-clockwise moment. Actuating force is also causing anti-clockwise moment, and friction force is also causing anti-clockwise moment. About which point? About hinge point. Then this case is said to be a self-energizing brake condition. However, self-energizing is something of use. The amount of effort get reduced for such cases. But it is also possible that in this case self-locking can occur. And self-locking, when it will occur, then it will cause, you can say, it can cause accident. So self-locking is not considered right, but self-energizing is good only. However, we have to keep in mind that A, B, and C should be such that that P should not reduce to zero. Or you can say B and C should not be such that that the friction force and the normal action force can balance out each other's moment. In that case, we will say that external actuating force is not required in order to apply friction. Okay, so if P is less than equal to zero, then in that case we say we are going to take this very example only. But you don't have to memorize anything. Try to understand, you don't have to memorize anything. Why? Because this A, B, and C will not be like this only. Okay, it can be anything. It is possible to have zero value of C. It is possible to have zero value of, or 2 times value of A. Anything is possible. Or you can even get something where you will not be able to decide that which is A, which is B, and which is C. Are we clear? So you don't have to memorize anything. You just have to understand one concept, that the moment because of friction and the moment because of normal are balancing out each other, and because of that the actuating force becomes zero. Whenever the actuating force becomes zero, then in that case we say that this is the condition for self-locking brake, which is possible only in case of self-energizing brake. Whenever the moment because of friction and the moment because of actuating force are in same direction, then in that case only it is possible to have such situation of self-locking. Are we clear about this? Point, class? Okay, so just tell me, let me tell you this relation. That P into A plus B. In this case, P into A plus B was how much? it was equal to N into B minus F into C. N into B minus F into C. What is F? F is mu into N. F is mu times N. So you can say that N into B minus mu N C. This is P into A plus B. If I am saying that, I want to determine the relation between A, B, C, whatever it is, when this is self-locking brake, when the brake becomes self-locking, then if I will say that in order to become the brake to be self-locking, then in that case P must be less than equal to 0. P must be less than equal to 0. So we can say that NB minus NB minus mu NC must be less than equal to 0, or you can say that mu must be greater than equal to B by C. Mu must be greater than equal to B by C. This is the situation. This is the situation for self-locking. In this particular case, you just have to keep in mind that this is the situation. This is the concept basically when we will say that okay, now our brake is self-locking brake, which is not desirable, at all. Okay, we want to have this control over the brakes. It is not good to have a brake where it will apply by its own. Okay, however, it appears good that the brake will apply by its own, but this is very critical situation, and it will cause hell lot of accidents. Okay, so P must be less than equal to 0, and for that mu must be greater than B by C. Or try to understand this friction whenever greater than some dimension ratio, then in that case we can consider that okay, this is our self-locking brake. If I will talk to you, so you got the idea of self-energizing, which was again an important point as far as gate was concerned. You got the idea of self-locking also. Now, if I will say that, what about brakes? So brakes can be studied in 3 parts. One is block brake, another one is band brake, and when I'm saying band brake, then it can be simple band brake or differential band brake. Simple band brake or differential band brake. When I am saying simple band brake, then how we define simple band brake, and when I am saying differential band brake, then how we define differential band brake, I will tell you like that. But here the block brake is also again classified into 2 parts: short block and long block. Okay, short shoe, long shoe, corresponding to the angle which it is projecting, on the center. Say for example, this was our block. If it is projecting some angle on the center which is less than 45°, then in that case we say that okay, this block is a short shoe block brake. But if this angle becomes greater than 45°, then in that case we say greater than, even up to 45° also you are going to use same thing only. If it is greater than 45°, then in that case we will say that it is long shoe brake, but it is not in our syllabus. I'm talking about simple band brake and differential band brake. What is simple band brake? Say for example, this drum is there which is rotating in a particular direction, and you have to apply torque. With the help of lever arm. Okay, so if one end of the band, this is from black we have represented band only. So if one end of our band is ending at the fulcrum, is ending at the hinge point, you can say, is ending at the point where the lever is attached, lever is hinged about that point, then in that case we will say that this is our simple band brake. And here it is not possible to have a self-locking condition. Why? Because here it will be T1 or T2, whatever it is. Causing anti-clockwise moment, and correspond in order to balance that anti-clockwise moment, we definitely need some P. So here it is not possible to have self-locking condition. But when we are talking about differential band brake, then in that case it is defined as no end of our band, is ending at fulcrum, and so we can say, it is the value of A and B, which will decide that whether this break will be your self-locking or not, okay. So this is P. Now we have to decide that which one will be T, which one will be T1, and which one will be T2, which one will be T1 and which one will be T2. In both cases, same concept is there. In order to understand that, we should be very much concerned about what is the direction of rotation of the drum. Now if the direction of rotation is clockwise, then in that case this will be your T maximum and this will be your T minimum. Why? Because we need an anti-clockwise torque. And for that T1 must be greater than T2. The braking torque will be that, in that case it was mu n into r. Friction into the radius of the drum. Here it will be T1 minus T2 into r. R is the radius of the drum, and T1 and T2. T1 is the greater value of tension. T2 is the lesser value of tension. Okay, so this is another formula. MT is equal to T1 minus T2 into R. Which one will be T1? T1 will be that out of these two, T1 or T maximum will be that one which is causing moment in opposite direction. You should be very much concerned that this is only point to understand that the moment because of this braking torque will be, or the braking torque should be opposite to the sense of the rotation of the drum. If it is clockwise, then the moment which we should be getting must be anti-clockwise. So MT is equal to T1 minus T2 into R. And what is the relation between T1 and T2? So T1 by T2 is equal to e raised power mu theta. T1 is T maximum, T2 is T minimum. For as far as our conditions are concerned. So T1 is T maximum, T2 is T minimum, and it is equal to e raised power mu theta, where mu is the coefficient of friction between the band and the drum surface, and theta is the angle of wrap. It can be anything. Okay, but we have to keep it in radian. Is it clear? Here also, say for example, if I will say that it is rotating anti-clockwise, then in that case, if I will say that it is rotating anti-clockwise, then in that case here it will be T1 and here it will be T2. Okay, let me ask you one question. In order to check your understanding. Determine, in this case, in this simple differential band brake, simple band brake case, please tell me in which case actuating force will be large. When it is rotating clockwise, when the drum is rotating clockwise, or when the drum is rotating anti-clockwise. Please tell me in which case the actuating force will be large. We require a large value of actuating force in order to have the same conditions, in order to have the same braking torque. Case 1 is when it is rotating clockwise, and case 2 is when it is rotating anti-clockwise. One is P1, and one is P2. Which of the two will be greater? P1 will be greater or P2 will be greater? I am telling P1 and P2 are the actuating force which is required in order to break this drum to equilibrium, to rest by applying empty braking torque, which is equal to T1 minus T2 into R. I'm just asking in which case it will be lesser. Tell me. In which case it will be lesser. Try to understand this. These dimensions are Okay. Just understand here. This dimension is already provided to you. This is A. This is A. Good, Rohit. Let's see. Let's see. This is A and this is B. These things will be provided to you, and it will be provided that actuating force is applied at a distance B from the axis of rotation. A is applied at a distance. T1 is applied at a distance A. If I will say that from here you can conclude that okay, T into A must be equal to P into B. T into A must be equal to P into B. Now A and B are constant, so P is proportional to T. P is proportional to T. Now if it is rotating anti-clockwise, if it is rotating anti-clockwise, then this T is T1. Then this T is T1. Are we getting this? Are we getting this? If it is rotating anti-clockwise, then this T is, just a minute class. Okay, so I was saying that if it is rotating anti-clockwise, then in that case, what is happening? Then in that case, this T becomes T1. This T becomes T maximum, and corresponding to T maximum, you will be getting greater value of P. You will be getting greater value of P. If it was rotating, say clockwise, then in that case, what will happen? This will become T1 and this will become T2, and corresponding to that T2 only, you are required to have some actuating force P. So we got that for anti-clockwise rotation, this T will be T maximum. This T will be T maximum. Corresponding to that, the P actuating or P required will be also greater. P required will also be greater. I think this point you got that, and this point is understood to you. This point is very important. Okay, this is something which understanding wise you should have this idea. They can ask from you for same amount of braking torque, what could be the ratio of actuating force corresponding to clockwise and anti-clockwise rotation? Corresponding to clockwise and anti-clockwise rotation. This can be the question. Okay, so you should be having this idea that okay, corresponding to anti-clockwise, we will be getting some different value of P, some different value of actuating force, and corresponding to clockwise rotation, we will be getting some different value of actuating force. So in order to have that ratio, so and so is the condition. Are we clear? Are we clear, everyone? So these are some points which you should keep in mind. These are some points which you should keep in mind. By understanding wise only, there are some points as far as brake is concerned, or brake is very easy for us. Brake is very easy for us. Okay. Now moving to the next question. A rivet joint considered for 4 identical rivets is subjected to an eccentric force of 5 kN. Determine the diameter of the permissible shear stress. Determine the diameter of the rivet if permissible shear stress is this much. Okay, so the question is very easy only. Again, we will go through the complete revision of this topic. I am talking about joints. So in joints, you should be having some idea regarding the terminology. Okay, single fillet weld, double fillet weld, single strap, single fillet weld, double strap, double fillet weld. That first thing. So terminology you should be having the complete idea of. That you will see from your notes. Okay, that these terminologies must be very clear to you. Apart from that, if I will say that what is the strength of joint, what is the efficiency of joint, so they can ask you about the efficiency. They can ask you about the efficiency individually as well. Crushing efficiency is how much, tearing efficiency is how much. That is also possible. Okay, so efficiency is the second point which you should keep in mind. Apart from that, simple loading condition, when there is no eccentricity, and we are talking only about when the line of action of the force is passing through the center of mass or centroid of the group of rivets. Okay, so non-eccentric loading, and another case is eccentric loading. Eccentric loading, what we see, that the line of action of the force which is applied on the system is not passing from the center, is not passing from the center. Here also there are certain cases that in one type of eccentric loading we are getting both primary and secondary load as a shear load. In one of the eccentric loading we are get primary as a shear but secondary is a tensile. Okay, so these are some things which we have already gone through. You can just go for the division. It completely depends upon the question, it completely depends upon the figure. You should have understanding, say for example, if I'm telling you, if I'm taking some cases. Okay, what is primary, what is secondary? Primary is something which is representing the balancing of translatory effect. Secondary is something which is countering the effect of rotation, okay, which is countering the effect of you can say moment. So let me ask from you, so this is my joint, and here I have applied only moment. Here I have applied only moment. So what will be the primary, what will be the secondary? So primary here will be 0. Primary here will be 0. Okay, what will be the secondary? Secondary here will be corresponding to this empty only, and it is very easy to calculate because of the symmetrical, because it is symmetrical. So we can say that every one of them will be equally supporting this amount of load, If I will say instead of this, loading is like this, please tell me what will be the primary load, what will be the secondary load, what will be the primary load, what will be the secondary load. If I will say that this is the P which is acting, so how you are going to determine? Say this is the case, then in that case how you are going to determine? In as far as primary load is concerned, transitive effect is concerned, it will cause shear only, so primary load will be shear load, but the secondary load will not be shear. In this case it will be tensile load. Secondary load will be tensile load. Why? Because of this load, P, we can say that P will have two effects, one is transitive effect and one is the rotational effect. Because of this rotational effect, this whole system will start rotating about this point O, and corresponding to that, here and here we will be having some sigma, this will be, the value of sigma will be proportional to this, the distance of center of rivet, from the point of rotation, which is point O. Here it is not rotate about the centroid of the group of rivet. It will rotate about point O. So is the geometry. Say for example, if I will say that okay, instead of this case, instead of this P, there is only a moment. Then in that case, what are the situations? Okay, so these are some points which they haven't asked in previous case, and these are some points which you can say that it is not that much important, but still you should have this understanding that okay, if so and so is the loading condition, then corresponding to that primary load is this much and secondary load is this much, or primary stress is this much and secondary stress is this much. Okay, or at least you should understand that what should be the name of that. Say for example, this is our loading condition. A moment is applied, only a moment is applied. Then please tell me what will be which one will be the zero, which one will be zero, primary load or secondary load? Which one will be zero, primary load or secondary load? If this is the situation and I'm asking that which load will be zero, then what will be your answer? Primary load or secondary load? Primary stress or secondary stress? Please tell me. Primary stress or secondary stress? Which will be zero? Here it will be the primary stress will be zero. Primary stress will be zero. Only secondary stress will be there, and that too we can calculate. We know that how to calculate those points. Are we getting this? Are we getting this? Class, everyone, are we getting this? Primary will be zero. Primary is something which is corresponding to the translatory effect. Secondary is something which is corresponding to the rotational effect. Here there will be no primary shear load. Here there will be only secondary axial load. Here there will be only secondary axial load. Is it okay? It is just the understanding which you should be having corresponding to the given diagram. Corresponding to the given diagram. This I don't know whether you are getting this diagram or not. This is the side view. This is side view of something. If I will say that from left, if I will start watching it from left, then it will appear like this. It will appear like this. Okay, so this whole system is rotating about this axis. We have to calculate the stresses corresponding to that rotation, and corresponding to that we will say that okay, this one is the rivet which is in critical condition, which is having the maximum value of sigma. This is having the maximum value of sigma. Okay, this is just for understanding. Apart from that, it can be in any possible way. It can be in any possible way that they can ask the question. Let me ask some more cases. Okay. Here it is something like this. Okay, this is the side view. If I will ask that okay, when transverse load is acting like this, eccentricity is there, but because of this eccentricity, what type of stresses it is going to have on the rivets? Okay, if I will ask from you, then you will say that because of primary effect, the translatory effect, everyone will have the equal amount of shear force. They will balance them equally. And what about the rotational effect? The rotational effect will be having this body, this system or this angle to rotate about point O dash, corresponding to that it will be having one value of sigma. So this will be sigma 1, this will be sigma 2, and of course sigma 1, sigma 2 will be proportional to, or you can say F1 and F2 will be proportional to the radial distance, or you can say the distance from the axis of rotation, from the axis which is passing through, from the axis which is perpendicular to the screen, and it is passing from O dash. Okay, so these are some idea that here you will be, as far as secondary stress is concerned or secondary load is concerned, that will be tensile load, and as far as primary is concerned, it will be shear load only. Everyone, is it correct? Okay, so I think you must understanding that from diagram only how you are going to get that which type of stress or which type of load we are getting as far as primary and secondary conditions are concerned, primary and secondary loading are concerned. Okay, here also, so these are the points which we should keep in mind. let's start for this question. Rohit, are you getting this? Okay, so we can say that here also we can easily find it that here it will be primary as well as secondary corresponding to this loading condition. Here it will be primary as well as secondary corresponding to this loading condition. What will be the primary? Primary will be the corresponding to translatory effect, and because say for example if I'm going to shift this load to the center of the group of rivet, if I'm going to shift this load to the center of the group of rivet, then how it will appear like. Right now I am talking about primary. Right now I'm talking about primary effect. We have shifted this to centroid. It will be like this: 1p and 1pe, 1p and 1pe. P is causing the translatory effect and P is causing the rotation effect. Now we are calculating the translatory effect. So here it is P, and in order to balance this P out, we will be getting P1, P2, P3 and P4. Translatory effect asks each and every point of this system to move by same amount, okay, to move by same amount as far as linear displacement is concerned. That is how we define translation, है ना? So we will get displacement of, or you can say that small displacement or small uh, deflection of these all these points by same amount. Corresponding to that, we will get the value of P1, P2, P3 and P4 of same amount, and it will be P1 is equal to P2 is equal to P3 is equal to P4. P1 is equal to P2 is equal to P3 is equal to P4 is equal to how much? P by 4. This is your first case, which in this case it will be 1.25 kilo Newton. Here in this case it will be 1.25 kilo Newton. Now what about the PE? If I am talking about PE, so this P you can made in two ways: either to show the effect directly or to show the effect which is balancing it out, so in first case, because we have considered it to be a balancing reaction forces, so we are going to do the same thing here also. Here it is PE, and corresponding to that, one rotational effect will be there, because this is clockwise, so this is anti-clockwise, this is anti-clockwise. Symmetry says that whether it is P1 dash, whether it is P2 dash, sorry, P4 dash, whether it is P3 dash or whether it is P4 dash, they all will be equal. Because P1 dash or P2 dash or P dash, you can directly say P dash is equal to C into R dash. C is constant for everyone, and here R dash is also constant for everyone. So you can say that P1 dash, P2 dash, P3 dash and P4 dash are also equal. Let's calculate the value first. So P1 dash is equal to P2 dash is equal to P3 dash is equal to P4 dash is equal to C into R dash. C is how much? C is P into E upon R1 square plus R2 square plus R3 square plus R4 square. Because everyone is equal, so you can say that 4 into R1 square. Okay, or just to make the revision clear, R1 square plus R2 square plus R3 square plus R4 square into whichever you want. Okay, P1 dash, P2 dash, P3 dash, P4 dash. Let's calculate the value of, because everyone are equal, so we are writing R1 only here. Here we can write PE upon 4 R1 square into R1. Corresponding to this, we will get PE upon 4 R1. PE upon 4 R1. Now, what is the value of P? It is 5 kilonewton. E, it is 200, and R is 100. Okay, so 5 into 200 upon 4 into 100. So this will be 2 only. So this is 2.5 kilonewton. 2.5 kilonewton. Now, try to understand this. Here P1, P2, P3, P4 are same. P1 dash, P2 dash, P3 dash, P4 dash are same. So we are only concerned about the resultant of these two forces. The magnitude of these two forces for every rivet is same. It is only about the resultant. Resultant do depends upon the magnitude as well as the direction between the direction of those two forces, or the angle between those two forces, you can say. Okay, so if I will say 1, then the angle between P1 and P1 dash is 90 degree. If I will say P2, then the angle between P2 and P2 dash will be 0 degree. If I will say P3, it is again 90 degree, and if I will say P4, means net resultant force on fourth rivet, then we will say the angle between P4 dash and P4 is 180 degree. Now we should understand, in order to determine the resultant, we are having under root of a square plus b square plus 2ab cos theta. So whenever the theta is 0, then in that case the resultant is maximum. The magnitude of resultant is maximum. And if theta is equal to 180 degree, then in that case resultant is minimum. This is something which we got the idea from engineering mechanics, or you can say from basic vectors. This can be applied only when this concept can be applied only when we are very sure about the magnitude of those two forces are same. If the magnitude are not same, then in that case we cannot directly say that okay, if theta is equal to 0, then the resultant of those two forces will be maximum, and theta is 180 degree, then the resultant of those two forces will be minimum. Okay, are we clear about this point? This angle thing we are applying only after we are sure that okay, P1 and P2 dash, or say for example we are having two critical rivets, and in both the rivets the value of direct shear stress and the secondary shear stress are same. Direct shear stress and the value of secondary shear stress are same. Then in that case only we can apply this thing that okay, what is the angle between those two forces. Here it is the second rivet which is in critical condition. Why? Because P2 and P2 dash are same. Means P2 is similar to P1, P2, P3, P4, and P2 dash is similar to P1 dash, P2, P3 dash, P4 dash. But the thing is, the P2 and P2 dash is having 0 degree between them, so the resultant will be maximum, and the maximum force will be 2.5 plus 1.25 means 3.75. So P2 plus P2 dash will become equal to 1.25 plus 2.5. This will be 3.75 kilonewton. 3.75 kilonewton. Are we clear? Class, am I getting this? .75 kilonewton. Now let me ask from you, say for example in this case, if it was not the case, everyone please confirm this. Up till now it is okay. Say for example, if I will say that okay, instead of this is the distribution of rivets. That is the geometry of rivet. This is A and this is B. This is A and this is B. In this case, if I am going to draw this is B. In this case, if I am going to draw what are the forces because of primary load and what are the forces because of secondary load, then it will be P1, P2, P3 and P4, which are absolutely equal to each other. But what about dash secondary load. So here it will be P1 dash, here it will be P2 dash, here it will be P3 dash, and here it will be P4 dash. Here it will be P4 dash. Now if I will ask from you that whether it is very obvious to you to say that this one is critical force, or you have to decide in between two. You have to calculate the value of critical loading at 2 points. And what are those 2 points? Please tell me what are those 2 points. Please tell me what are those 2 points. Here, is it very obvious to you? Here B is greater than A, B is greater than A. Then whether you can directly say, okay, here also I know that which one is critical, or here you need to calculate 2 points, because you are having this doubt in mind that okay, now there are two possibilities of having the critical point. There are two possibilities of having the critical point, and what are those two possibilities? What are those two possibilities? Please tell me what are those two possibilities. Everyone, please tell me what are those two possibilities. If B is greater than A, if B is greater than A, then P2 dash, is obviously greater than P1 dash. Then P2 dash is obviously greater than P1 dash. Okay, now here the resultant will be P1 plus P1 dash, and here the resultant will be under root of P2 square plus P2 dash square. P2 square plus P2 dash square. This value can also be greater than this value. This value can also be greater than this value. Why? Because here the P2 dash is greater than P1 dash. Here the P2 dash is greater than P1 dash. So the resultant can be greater. So here you have to find the critical loading condition at both 1 and 2, or even 4 also is having the same condition as that of 2. So at 1 and 2 or 1 and 4 you have to check. Are we getting this point? Are we getting this point? Here there are two critical points which are possible. Basically, critical point will be one only. But as far as geometry is concerned, without calculating, we cannot directly say that okay, this one is our critical point. Are we clear? The resultant do depends upon the magnitude as well as the angle between those two forces. So if the magnitude at every point is same, then in that case it is very easy for us to determine which one is critical just by angle between those two forces, primary force and secondary force. But if we are not very sure about the magnitude of the forces also, then in that case we have to consider both the facts, and we can, from here we can say that okay, point 1 can also be my critical point, and point 2 or point 4 can also be my critical point. Are we getting this point? Everyone, are we getting this point? Please comment. Please comment in chat box. Are we getting this point? Okay. Now others, Pranav, Rohit, others, what about you? Are we getting this point? Here we have to calculate corresponding to both 1 and 2 or 1 and 4. So we got the value of net force to be, we got the value of net force P to be how much? If A and B are same, then this will be the same situation now. Vijay, if A and B are same, then this situation which we are discussing in this question, then in that case this will be the same situation, and we have find that okay, the rivet which is closer to that of a centrifugal load will have the critical loading condition. However, you don't have to memorize anything. You can find it by yourself. Okay, P2 and P2 dash are acting in the same direction. So these two forces will result in the larger magnitude of the force acting on a rivet 2, and therefore corresponding to that the stress will be maximum at rivet 2 only. So we have to design as far as rivet 2 is concerned, as per rivet 2 only. Okay, here you can say the value of P is equal to 3.75 kilonewton, means 3750 Newton upon pi d square by 4 is equal to, in question what they have asked, determine the diameter of rivet if the permissible shear stress is 60 megapascal. So pi d square by 4 is equal to 60. Why I'm writing directly 60 over here? Because the value of d whichever I will be getting from here will be in mm only. Okay, which I will be getting here will be in mm only. So you can directly solve it. 3750 into 4 pi 60, 8.92. So d will be 8.92 mm, or you can say that it will be 9 mm. In order to have safe design, the value of dia of the rivet, should be 9 mm. Okay, now let's move to the next question. A plate 75 mm wide and 10 mm thick is joined with another plate by means of a single transverse and double parallel fillet weld as shown. The joint is subjected to the maximum tensile force of 75 kilonewton. The permissible tensile and shear stresses in the weld material are 70 and 50 megapascal respectively. Determine the required length of each parallel fillet weld. Now here there are few points which I should clear to you. First thing is, if I will ask parallel fillet weld, in parallel fillet weld, which force is responsible for failure? Then it is shear force. It is very easy for us to determine. It is shear force, and of course the area will be corresponding to the throat area. Throat area is what? It is corresponding to the minimum width. Say for example, this is our weld. Then in this weld, just see here. Say this is our weld. Then corresponding to this weld, we can directly say, let me make a broader diagram over here. Okay, now this is our weld, and we can say that, okay, what this length is? This length is called as h. This length is called as h. This is termed as leg. Whenever the dimension is provided, corresponding to weld, then it is provided corresponding to leg only. Okay, the weld is of this much size. Then they are telling you only about leg. Is it clear? If they are telling you precisely that, okay, the throat is this much size, then you should be taking that data to be of t. This is our throat. This is the minimum width. Corresponding to that, we will be having minimum cross section area, and corresponding to that, if the loading is parallel loading, if the loading is parallel loading means the axis of load is parallel to the length of the weld. I'm not talking about leg of the weld. I am talking about length of the weld. If I will say for example, this is okay, and loading condition is like this. I think you are getting this 3D view. So if the loading is parallel to the longitudinal axis or length of the weld, this is length of the weld. It will be represented to you by L. Then in that case, it is parallel fillet weld, and it is the shear force which is responsible for the failure. But if you're talking about transverse fillet weld, then in that case, the things got little complicated. Sometimes we say that it is the normal stress which is responsible for failure. Sometimes we say that it is the shear stress which is responsible for failure. Why? Because it is all the type of loading which is actually acting in a transverse fillet weld. Okay, so how to approach such questions? In that case, you have to approach as far as data is provided. As far as all chapters, शोभित, हम लोगों ने ये दूसरा सेशन चल रहा है बेसिकली. पहले सेशन में हमने कवर कर लिया है काफी कुछ, ये दूसरा सेशन चल रहा है और इसमें भी हमने, अगर मैं कहूं कि कौन कौन से चैप्टर हो चुके हैं, तो मेरा ब्रेक हो चुका है, क्लच हो चुका है और जॉइंट्स का पहला पोर्शन हो चुका है. ठीक है, जो रिवेट वाला पोर्शन है वो हो चुका है. हम यहाँ पे बात कर रहे हैं वेल्डेड जॉइंट की. तो सारे चैप्टर कवर हुए हैं या फिर हो जाएंगे. जो भी अभी बचा हुआ है, एक आध चैप्टर और बचा हुआ है, वो भी कवर हो जाएगा. और ऐसा सारे ही सब्जेक्ट के लिए है. ठीक है. So what I was saying is that here how we have to approach as far as data is provided in the question. If they haven't talked about sigma t, then we have to design as per tau only. However, the load carrying capacity of a transverse fillet weld is greater than that of a parallel fillet weld by 1.18 times, because the angle at which the maximum shear stress is acting is 67.5 degree instead of 45 degree. Corresponding to that, we are having greater value of area, and corresponding to that, we can say that we can have the greater value of tau as well. We can have the greater value of sigma as well. Sorry, shear force as well. Okay, so we say that the load carrying capacity of transverse fillet weld is greater than that of parallel fillet weld. But as far as design is concerned, we always go, say for example, if sigma t is not provided in the question, then how we approach? We approach very simply. We make our design very simple, that we are assuming the failure is occurring at 45 degree and it is occurring because of shear only. However, in actuality, it is sigma also, it is moment also, bending moment also, it is tau also, which is actually acting in that way. Okay, but from simple point of view, from safety point of view, we consider that okay, at 45 degree our failure is taking place and it is because of shear. Okay, so these points you got the idea of that what is transverse fillet weld, what is parallel fillet weld, and corresponding to that which is having the greater load carrying capacity, and how we have to design. Ultimately we have to design keeping in mind that okay, tau is the cause of failure and it is acting at theta is equal to 45 degree, or you can say throat area. Okay, you can say corresponding to throat area. The point is, say for example, if in question they have provided the value of sigma t as well, then in that case you have to design as per sigma t, but still the angle or the plane or the area which you are going to take is the minimum cross section area or the throat area. Are we clear about this point? Class, are we clear about this point? Is it okay? Is it okay? Everyone, please confirm it. Okay. After watching this session and again moving to the previous year, of course I know that you are going to solve previous year once more. Okay, after watching this session and going to the previous year, every confusion of yours will be over, and most of the topics we are revising. Already we have taken one session which was very important, and we have covered everything like fluctuating load, like bearing. Most of the points whichever was possible to discuss, we have discussed already. Okay, now apart from this type of loading, what are the other points which we should be aware of? This is your shaft. This is your shaft. And this is the rivet. This is the rivet. Then in that case, there are two possibilities of framing the question from here. There are two possibilities of framing the question from here. One is that this system Yeah, size of weld is same as leg of weld. Size of weld is same as leg of weld until and unless they haven't mentioned minimum thickness or they haven't mentioned throat. Then up till that you have to take only the H. Up till that you have to take only the H. Whatever term they are using. Pranav, are we clear? Okay. So from here, they can ask basically this is also not very important, but still it is possible to ask from this point also that what if this portion of my shaft is under torsional load, is under torsional load, or what if it is under moment, corresponding to that also you must have the idea that what will be the value of tau and what will be the value of sigma, okay. So these are some formulas which you should keep in mind, which you should go through the revision, and apart from that, as far as Rivet is concerned, there is no other points which we should be concerned of. Okay, now moving to the question. The question says that a plate 75 mm wide and 10 mm thick is joined with another plate by means of a single transverse double parallel fillet weld. The joint is subjected to the maximum tensile force of 55 kilonewton. P is given as 55 kilonewton. The joint is subjected to the maximum tensile force of 55 kilonewton. The tensile and the shear stresses. Here they have provided about sigma and tau separately. So we have to consider sigma for transverse fillet weld. For parallel, always it is tau, but for transverse, it could be tau, it could be sigma, depending upon the data is provided or not. If sigma is provided, then we have to take sigma only. Okay, respectively, determine the required length for each parallel fillet weld. So very easy. It is very easy. This question is very easy. The only thing is you should not get confused regarding when to take sigma, when to take tau. If sigma is given, you have to take sigma corresponding to transverse. If sigma is not given, you can take tau corresponding to transverse. If sigma is given or tau is given, whatever is given, for parallel you have to take tau only. So here you can say that 70 into area. Area is how much? 75 into T. Here thickness is provided for the plate. And from geometry we can conclude that okay, whatever will be the thickness, same will be the value of leg. Or size of weld. So here it will be 10 by root 2. 10 by root 2. This is the amount of load which is taken by the transverse, plus 2 times of, because we need to know the value of L only, 2 times of L into 10 by root 2 into 50 must be equal to how much? It must be equal to 55,000. 55,000. Keep in mind that as far as MD is concerned, the only thing which you should be concerned about is the units. You have to keep your glance on the units. You have to keep thinking that, okay, whether I'm putting the units appropriately or not, whether it is Sommerfeld number, whether it is Petrov's equation, everywhere. Okay, diameter is provided, radius is provided, first thing that, and the second thing is whether the unit is correct or not. Okay, so here let's calculate it. 55,000 minus, so L will be how much? L will be equal to 25.29. L will be how much? L will be equal to 25.29 mm. L will be how much? L will be equal to 25.29 mm. Okay, now moving to the next question. Last question, the question which is from Spring. The question which is from Spring, we can say that, okay, from Spring only three formulas are there. From Spring only three formulas are there which are of concern. One is tau, another one is delta, and another one is stiffness. One is tau, another one is delta, and another one is stiffness. Just wait, right now, no need to go for the calculation. Just wait for a while. Okay, so the terms and terminologies which are important to us. Let's begin from there. So here it is. We calculate the value of spring index. First is spring index, capital D by small d. Capital D is the coil dia, small d is the spring wire dia. Small d is the wire dia. Okay. Coil dia, wire dia. C is the spring index. Of course, greater than 1. Much more than 1. Okay. Now, second thing is tau is equal to how much? Tau is equal to 8 PD upon pi d cube. 8 PD upon pi d cube. Which d is in numerator, which d in denominator, you should keep in mind. And apart from that, we have to write Kw also, Wahl's correction factor also. Tau must be equal to Kw into 8 PD upon pi d cube. How this comes? Let's revise it once. That tau is equal to 8 PD upon pi d cube. In general, how we have calculated this? We have calculated this by keeping in mind that, okay, one shaft is there which is of dia small d. One shaft is there which is of dia small d, and in that one moment is applied which is equal to P into d by 2, then corresponding to that, what is the amount of shear stress which is acting, what is the maximum amount of shear stress which is acting. So corresponding to that, we can calculate it here. Okay, the stress under torsion, we know about how to calculate. T by J is equal to tau by R. You can calculate very easily about tau. But here the things are little bit different. Here we are talking about spring. So in spring, we have to take two more factors into consideration. One factor is that while making this condition, we haven't mentioned about the direct load, which is P. We haven't mentioned about the direct load. It will also get shifted to the wire. Dia. And the second thing is, we haven't also considered about the curvature effect. The internal portion will be having greater value of sigma than that calculated considering it to be a straight chart, considering it to be a straight chart. So we haven't considered two things. One is direct shear and the second thing is curvature effect. So if we are going to calculate both of those factor, both of those also into our account, then in that case we will say kW is equal to how much? Ks into Kc. Ks into Kc. Ks is what? Ks is direct shear factor. Kc is what? Kc is curvature effect. Okay, curvature effect we cannot calculate, but Ks we can calculate. Ks we can calculate. Let me tell you that also, but however that is not very important. Let me tell you that also how to calculate Ks. Ks is nothing but simply P upon area. P upon area. Okay, if you are taking the consideration, taking the effect of direct shear also, then it is P upon area. This is pi d square by 4. If I will say that, okay, now in actual the maximum shear stress will be 8 PD upon pi d cube plus 4p upon pi d square. Okay, now if I will say that, okay, in order to make the thing similar, we can multiply here to d upon small d. This is something which we can multiply, and so we have to divide also the same amount, d upon. Now this is same as this. This is same as this. We can take this out and we can say that, okay, 8 PD upon pi d cube into 1 plus d by 2d. 1 plus d by 2d. Now d by d is how much? D by d is how much? C, spring index. So we can say that this is 1 plus 0.5 by C. So if I will say, they can also ask that what is the value of direct shear factor, then it is 1 plus 0.5 by C. However, it is not that important. But actually the value of direct shear stress is 1 plus 0.5 by C, and it can be calculated over there also. That is why I am telling you, they keep on asking such things which can be calculated over there. Okay, so try to understand that this is not very tough. The value of Ks you can calculate directly. Ks is something which depends upon experiments and all, so you cannot directly calculate the value of Kc, but you should know the value of Kw also. So Kw is 4c minus 1 upon 4c minus 4 plus 0.615 by C, plus 0.615 by C. Very important formula, very important formula. Directly they can ask about, please tell me about the Wahl's correction factor. Please calculate the Wahl's correction factor for the given value of spring index. This is also possible that in one number, in 1 marks they can ask. Okay, or they can frame question which will require the value of Kw as well. Okay, this is the first point. So you have considered the formula of tau as Kw into 8 PD upon pi d cube. Apart from that, another formula which you should keep in mind is delta. Another formula which you should keep in mind is delta. Delta is how much? Delta can be calculated as 8 PD cube n upon gd raised power 4. 8 PD cube n upon gd raised power 4. gd raised power 4. Again, keep in mind which d is in denominator, which d is in numerator. Okay. Here some more terms are introduced. N is the number of active turns which will be provided into the question. You can also have the different condition or the different number of active turns corresponding to different end conditions, but that is not in our syllabus. Number of active turns, it will directly be provided into the question. Okay, number of active turns, and n is number of active turns. G is modulus of rigidity. Every one of you is aware of strength of material, modulus of rigidity. D we already know, capital D we already know. P is the amount of axial load which is applied. P is the amount of load which is applied. P is the amount of load which is applied. Okay, so this is another formula which we should keep in mind. Now, if I will ask that, okay, one more formula they keep on asking, that formula is the stiffness. They keep on asking about whether you are having this idea of stiffness or not. If they will ask about the stiffness, then in that case, how to approach? If you have learned about this delta, you don't have to learn about the stiffness. Just understand this, that P is equal to how much? Load can be written as K into delta. Load can be written as K into delta. Okay, where K is the stiffness. Same thing here also you can do. that okay, if you are writing this equation in this term, then it will be P is equal to G d raised to power 4 upon 8 d cube n into delta. So this is our stiffness. This is our stiffness. On equating, we can consider that okay, stiffness is nothing but G d raised to the power 4 G d raised to the power 4 upon 8 d cube n upon 8 d cube n. Everyone, is it clear? Class, are we getting this? Are we getting this? Are we going through the revision? This is the quickest way of revising things. This is the quickest way of revising things, and keep on watching how to apply also, and keep on watching how to apply also. So we are applying also at the same time, and we are also watching the formulas. Now, apart from that, there is one more thing: spring in parallel, spring in series, which is important to you. Spring in parallel and spring in series. If I'm saying spring in parallel, then by that I means equivalent is equal to K1 plus K2. K1 plus K2. If I'm saying spring in series, then here what I mean? Here I mean 1 by K equivalent. 1 by K equivalent is equal to 1 by K1 plus 1 by K2. Okay. How we are concluding these two formulas? We are concluding by the fact, if you are talking about spring in parallel, then we are talking about a condition. Where both the springs are oriented in such a way that amount of force is balanced by both of them. Means P1 plus P2 is equal to P. P1 plus P2 is equal to P. The amount of force which is applied on spring 1 plus the amount of force which is applied on spring 2, or the applied by spring 2, basically countering the effect of P. So we can say that P1 plus P2 is equal to P. This is the first condition. Second condition is delta 1 is equal to delta 2 is equal to delta. If we are considering this equivalent condition, we are replacing this whole system by a single spring, and we can say that okay, the delta, the elongation or the contraction, whatever you can say, for first spring is equal to that of spring 2, is equal to that of second spring or the third spring also. Then in that case only we can conclude that okay, these two springs are in parallel. And from here you can easily conclude, because F is equal to, or you can say P is equal to K delta. Delta is same, so you can directly say that delta 1 is equal to P1 by K1 and delta 2 is equal to P2 by K2. Sorry, P1 plus P2 is equal to P. So P1 can be written as K1 delta, P2 can be written as K2 delta, and P can be written as K equivalent into delta. From here the delta can be cancelled out from each side, and K1 plus K2 becomes equal to K equivalent. Just a second, class. Okay, second thing is if I'm talking about series, then in that case two springs are said to be in series if the load which is acting on one spring is same as that which is acting on another also. So this P is same force which is acting in spring 1 also and spring 2 also, same as that of shaft. If I will ask